likely to give you fractional values in your factorisation, so you would expect to have whole numbers that are factors of your coefficient of x squared, your coefficient of the x, and the coefficient and the minus 6 there. Okay, so these 15 prime numbers, 3 times 5, it doesn't always work out with just 2, there could be several. Here we have 2 times 3. Now the thing about this, look, x squared plus 15. Now that could be minus 3 times minus 5. It could be plus 3 times plus 5. So that immediately introduces another combination set for your possible solutions. They would expect you to try out all different things until you find the ones that worked. I'm going to show you a method that avoids doing that. This value here, there's a 1, right? So if I multiply that by a half, I indeed get a half. Keep that in mind. That's 6. If I multiply that by 15, I get negative 90. We want two numbers such that this value here plus some unknown times that value there minus some unknown equals this here, negative 90. And this is the same sort of procedure to give you that value there, just that we've modified it because we want factors to take into account this 15, so we've included it in there with the multiplication, in that we've got negative 90. Now if you have that situation, look, a minus b, this is one you really need to remember, a plus b, that is in fact turns out when you multiply it, oops, squared minus b squared, right? That is important one to remember. So what we got here, we've got half squared minus n squared equals negative 90. Right, now this in fact becomes a quarter minus n equals negative 90. Now when you start moving things around, whoops, ooh, nearly forgot. Okay, so I've squared that. I nearly forgot to square that. Right, when you mess around with these, move things about, what you end up with is n equals 19 over 2. We substitute that back in here. So what we end up with, and these become two values, we've got a half plus that value there. Right, that's one value. I'm going to put a comma between. We then got the half minus that value there. Okay, so that indeed gives us 20 over 2 and minus 18, isn't it? Minus 18 over 2, which in turn becomes 10 and minus 9. Now we have multiplied that minus 6, there's the minus 6, by 15. Now we do the correction at this point. Divide by 15. So we end up with 10 divided by 15. That's one number. The other number is 9 divided by 15. These can simplify. Now 5 will go into both those, so that becomes 2 over 3. And this one, 3 will go into both those, 3/5. Now look at what we do here. Leave a space, there's your x, 2/3 plus 2/3. Bracket, leave a space, there's your x, minus 3 over 5. That 3, we move to there. That 5, we move to there. So we end up with 3x plus 2, 5x minus 3. And that is your factorisation of that. You need to watch it a number of times. You really need to watch it a number of times. I would recommend that you actually build some. You know, for example, 4x minus 1, big numbers, 15x plus 32 if you like, you know, and you work out what that is in the standard form, and then you try applying what you've learnt here, see if you get back to that. You know, these are just example numbers. Start off using simple or low value numbers. You know, you could have 2x minus 1, x plus 9. No, keep it simple. 2. Right, you know, low value numbers, so your brain doesn't have to work so hard. Get your standard form, ax squared plus bx plus c, whatever the values are, and see if you can go through this process to get back to there. This system works very, very well. I've actually tried it on this one. 2.72x squared plus 12.8x plus 15, and I found it actually works. It gave me the correct ones. I built that from 1.3x plus 3 times 2.1x plus 5. See, so I knew where it should end up, and I'd applied this method to that, and I ended up back where I started from. There's a point, decimal point there. Right, try it. It's another approach. It's a different approach. Watch this a few times if you want to adopt this method. Practice it if you want to adopt this method. It's a bit advanced, but you know, it's entirely up to you.